Hello, my name is Demetria Guidry, and I decided to do my presentation over the cognitive learning theory. My goal was to simplify, define, and apply it, kind of break it down just for educators. The cognitive learning theory is otherwise known as the psychology of learning, and I pulled three main ideas from it that I thought might help us grasp a better understanding of it. One is the idea that learning is happening best when we are consciously aware of how we learn and process information. And this is otherwise known as metacognition. That we can intentionally use our intelligence and our cognition together to learn and retain information. And that lastly, it is pivotal to understand the way that the human brain processes information, and that process itself determines whether the information is lost or stored for further use. So what is metacognition? That is the knowledge and awareness about one's own learning. So this is our awareness about our own thinking skills, our own study skills or habits, our ability to self-correct. Just really being aware of how we learn and what we're learning at that time. So why is it important, or why does metacognition help in learning? Well, according to cognitive theorists, metacognitive skills make learning intentional, and they support our ability to make any necessary accommodations in order to gain the knowledge needed. So basically, if learning is intentional and we're always aware of how we learn, then we can increase how much we learn as well as how much we remember. So, if you are thinking about learning, cognitivists believe you'll be contributing to developing new pathways, or in other words, connections in the brain that will make learning easier for you. You will also identify learning strategies that really work for you and increase the amount of information that you are able to commit to and retrieve from your long-term memory. But an important part of understanding the cognitive theory is that brain research matters. Brain research tells us that there are times in our development when our brains are primed for learning certain information better than others. As an early childhood person, one of the things I think about when I think about the brain's development is children at the ages of 2 to 4. That is a time that we call language explosion. And because of brain research, we know that that is the best time to teach a child a foreign language. It's just that the brain is primed for learning language at that time. Brain research also tells us that certain areas of the brain are responsible for different cognitive processes, and what learning a person can do depends on whether the brain is developmentally ready in the area responsible for processing that particular information. But not everyone has the same wiring. Even those at the same age may not be ready for the same information. This just basically tells us that developmentally appropriate activities matter, that we don't all, even though we develop similarly, we don't all develop at the same rate. Brain research also tells us that the brain is always a work in process. We're always creating new pathways, new wiring systems, and this happens all the way to our death. And last, there are teaching/learning strategies that can be used to help increase the likelihood that information delivered to us will be stored and retrievable. Okay, so What are the implications for teaching? Well, a teacher must know, one, how their students learn best. Without awareness of how your students learn, you wouldn't know how to present information to them so that way they can store it, learn it, store it, and retrieve it. Second, if the content is appropriate for the cognitive level of their students. So we just need to know developmentally where they're at. And three, we need to know how to motivate our students' learning. There are ways that, every child every child is motivated by different things. But number 4 tells us that we need to know how to tie new information to previous information. And those two things kind of go together. If you can pull from a student's experience, then it usually motivates them to learn. They usually want to know more if it relates to something that's important to them. Well, how do students learn best? If you don't know, you can always give Gardner's multiple intelligence assessments. But if you do know, or you're aware of each student's way of learning, then you know already that it is important to teach to several different learning styles in every lesson. Gardner's multiple intelligence assessments tell you a child's multiple intelligence in all of these levels, in all of these areas that you see here in this picture. Okay, is the content appropriate for each student's cognitive level? There are many reasons that cognitive abilities differ. For many students, cognitive constraints exist in the brain, and we as teachers must adapt our materials to reach all the cognitive levels in our classroom. How to motivate student learning? Well, since not all students are self-motivated to learn, which would be a blessing for us teachers if they were, but because they're not, we have to develop strategies that increase a student's intrinsic desire to learn. Teachers can implement activities at which students are guaranteed to experience success and build on them. This will contribute to increasing their internal locus of control and make them more likely to attempt more challenging tasks. So basically, what this tells us is we need to make sure that the first time we present information that they succeed, and we give them something that we know that they can succeed at. That way it'll increase that belief in themselves. That internal locus is what cognitivists call this. And then the idea that we need to tie information to previous information. Well, cognitivists believe that we collect and organize information in schemas. Schemas are like boxes that hold all that we know about a particular thing. So this visual aid here, this shows us what a schema of a dog might look like for a young child. Maybe a child that's seen a dog only once in their life. It might only have that child might only have 3 details about the animal. One, that it has fur, tail, and 4 legs. Cognitivists believe that our previous experiences shape our existing schemas. So the only way that our schemas are revised is when they are presented with information that challenges what we have already have stored. So a teacher must find a way to present information so that a child can easily assimilate it into their schemas. So each time new information is introduced, cognitivists believe that if we have prior knowledge that supports the new knowledge, we are more likely to add it to our schemas. Piaget theorized that we add information to our schemas in two ways. One, that's by assimilating it, using previous information to understand the new information that is presented, and then accommodating it, revising your previous schema so that the new information fits and makes sense. So this example shows how Piaget theorized how we integrate new information. So the one on the left, assimilation, shows maybe a child that saw a dog for the first time. And the schema that the child made about the dog is that it's a four-legged pet. And the child will call this a dog because somebody told them this is a dog. And then accommodation side on the right, the existing schema shows still that the child believes this is a four-legged pet and it's a dog. But someone points out that a different animal they saw is called a cat. But at first, the child's going to try to put that into the only schema it has because it has four legs, so it must be a dog. Once the child is told it's a cat, it realizes that not all four-legged animals are dogs. Therefore, the child is able to create another schema, one representing a cat. In conclusion, the cognitivist theory relies on an accurate understanding of how the brain processes and stores information. That we are doing the most effective learning when we are cognitive of our own learning, and that when we are properly motivated, we can efficiently store new information in the form of schemas. When these ideas are effectively executed in a learning environment, it is possible to wire the brain for more efficient, higher levels of thinking. And that teachers, we play a pivotal role in this process when we are aware of the cognitive process.